Okay, well, thank you very much. This is a wonderful opportunity. My name is Joe Schmid. I'm one of the NASA flight surgeons here at the Johnson Space Center, and these slides were generated by Wes Tarkington and Andrew Madrid and our entire team. And basically, I'd like to show you today that we had a use case where we had the first holoportation from the Earth to the International Space Station, which we think is the first one to space ever. And a lot of folks online already know, but in case you don't, holoportation is basically taking a person and moving them to another location using holoportation software, using the HoloLens that we have on board, and taking that person to that location where the crew member can view the person in orbit as if they're floating right in front of them in a live image. The issue that we have as flight surgeons are that our patients are a long way away from us, 210 nautical miles and 17,500 miles an hour, as well as the next time we actually get to lay our hands on them might be 6 months away. So for us, it's the actual ultimate in telemedicine. In our background, a flight surgeon is assigned to each crew member and each crew on board. We take care of the crew members during their pre-flight, during their launch, all their training, the mission itself. We go out for their landing, and then we take care of them post-flight as well. We have the opportunity to do a weekly private medical conference with the crew members, and we normally have audio and video. We have a VC system we use. It's kind of like Skype. And then we could also, they will call us on our cell phone, and we can use the loops to go space to ground as well. We're very limited. We only get 15 minutes, 15 minutes with each week to talk with our crew members. We have email, etc. And we also can respond to, and we have to respond 24/7 on call. So we often get a telephone call for the crew members after hours. We provide routine ambulatory care. We also do all of the EVAs, supporting those payloads, and then work with the crew members on exercise countermeasures. We're also responsible and work in mission control for any of the emergencies that might happen and the effects that they can have on the human body, to include a depressurization, fire, toxicology release, a radiation event, and what we're really responsible for is any medical events. And as I mentioned, the crew members are really a long way away from us, and we are limited when it comes to the satellite connections as well. So our use case is to use this holoportation software, and holoportation, as you all know, has been around since I think around 2016 or so when Microsoft acquired it. We're going to do baby steps and test the software within the NASA system and on board step by step. And so our plan is to do one-way holoportation, which we've now achieved, a two-way holoportation where both the crew and the flight surgeon on the ground are wearing the HoloLenses and can communicate. And then in the future, we'd like to add haptics. We like to do the operational use to include, as I mentioned, the private medical conferences. We also have private psychological and psychiatric conferences that happen once a month. The crew members are away from their family members, and they do have family conferences, but they've never had a conference like this where they can actually have the crew family come on board in a live image. And when we get two-way, we'd like to have the crews come down from orbit and join the family, say at the dinner table for Thanksgiving dinner. And in the future, we'd like to bring mentors on board to include the engineers and the trainers, and to really experience this telework and tele-teamwork. Eventually, I think it's in the future, we're going to bring the general public to the station, and then also a lot of the managers and VIPs. And you can imagine that when we land back on the moon, we'd like to bring the president and other VVIPs there as well, and vice versa. So our concept of operations is that we do have a HoloLens 1, and I believe now we have 2 on orbit. We have We're using what's called EXA software. EXA Aerospace provides the HoloWizard software, and a Connect device, which is connected to a all-in-one machine. It's a very specific machine here in the Mission Control Center, and we load that software remotely. We are controlling our IP addresses, and then we run a script and a set of procedures to make the connections. The pictures here are notional. You see the two crew members wearing the HoloLenses, and then you see yours truly in a conference room doing a handshake with the crew members. Here's a picture kind of that lays out the system, and I believe Dr. De La Peña-Laca is also online as well and can help me with any technical questions. But basically, the holoportation software that's originated and adapted by EXA Aerospace is a C+ application, C# I should say, I'm sorry. And then we use the Connect software. And there, here's a schematic showing the upper right-hand corner, the equipment that we have in Mission Control and the connections there to the mission network environment that goes up through our WAN and then to White Sands, New Mexico, up through the TDRS data satellites and to ISS. And you'll notice that it does not go through the internet. We have and we do not use the Microsoft and other servers to use this. So it is a very controlled and a private network that we set up with the space station. Here's our schedule. We did the initial tests on the ground with the equipment in an analog method. We've gone through the procedures and the commands, as well as the information for the crew on board. And then always the challenge is to get the test onto the very limited timeline. As you know, we're competing with other payloads and other activities on board. And so scheduling is often very challenging, but we got it done. And so I'm happy to tell you that on the 8th of October of last year, we had our first holoportation of humans to the International Space Station into low Earth orbit. And then again, we repeated this on the 28th of February. We have a third session that's pending. Our upcoming AX-1, which is the private astronaut mission that's going to go up on SpaceX, they're going to utilize the same system for the two-way holoportation. And we hope that both will be successful and we'll be able to turn this into an operational use. Here's an image of that first holoportation to space. And it was, this is an image taken from the HoloLens. So it's a pixelated image showing of a video that was going on. And Thomas, who's the European astronaut, placed me in the middle of the lab there. Interesting thing about the HoloLens is, and the holoportation software is, that you can come back 3 minutes or 3 weeks later, and I would be in that same position if the image is live. So really very interesting. We also did this is a picture from the second session, but we did a handshake, and we're doing a left-sided handshake here because the crew member had to use her right hand to be able to click and take the pictures of that. But you truly feel connected to the crew member on board. The experience is unlike anything I've done as a flight surgeon on the telephone or on Skype or audio, video, etc. You really feel that you're connected with that crew member, and they had some interesting responses as well. The objectives of our holoportation, of course, were to do this historic connection and then confirm with historic handshake, and then to really show some tele-mentoring and demonstrate from a physician to demonstrate what's called a cranial nerve exam, which are the basic nerves that come out of the brain. And if you've ever been examined by a physician looking at your nerves, this is one of the tests that he or she will do. So we ran through the ocular motor functions and tested visual fields, and then the rest of the cranial nerves. And then I had the opportunity to take the CEO of AXA Software, who's also one of the co-developers, and I used his knee actually to do an orthopedic exam and show that to the crew member. And then we showed documents, and then really did have the interaction and to the experience of a flight surgeon interacting with their patient on board. Here's some additional images that were taken. The upper left-hand corner is showing one of those documents, and just after I'd done a knee exam and showed that to the crew member. And then I grabbed everybody that was in the support room there, and we all were holoported to the space station. It really felt like we were in the middle of science fiction. Here's some still images of the demonstrated some upcoming two-way holoportation. The upper left-hand corner is showing there's a person that's in, the co-director, Nathan Ream, who is in Alabama, and he's being holoported into the library office of Fernando de la Peña Laca, and that's the image you see in the left-hand side. And the right-hand side is the image of what Nathan in Alabama is seeing, and they interacted real time and quick and experienced that. The challenges of this are to get on board the space station. As I mentioned, you're competing with every other payload and all the normal activities to maintain the space station and to do EVAs and such. The network at NASA is also challenging. You have to get, of course, the reviews and the proper safety and other permissions. And in this case, we were really pushing all the network development as well. And we did this with 5 megabytes. You may have seen on YouTube and other locations where there's some really beautiful pictures with Holoportation and HoloLens software. It usually involves multiple cameras and large bandwidth. But we were challenged with just a 5 megabyte bandwidth to the station and back and a Kinect camera. But it was indeed effective. And also the challenges of doing remote software loads as well as connecting the equipment and manipulating the files. And it literally took us about 5 months or so to get our pictures down. And lastly, we did this with no mandate by anyone other than really trying to do some innovation, no real funding, and also no one had done this prior in this kind of environment. So we were successful. We had a good communication with audio and imagery as well. And then initially, the first holoportation session, we actually had to use space to ground loops. And the second one, we were able to actually use the devices themselves. It sounds simple, but it really are. These baby steps are big steps. Also was challenging was placing the module or the image within the module itself. The HoloLens can be fooled a little bit as it scans the environment due to the clutter of the space station with all the equipment and wires. Also, interestingly, when one of the other crew members floats by in the environment, that can also challenge the HoloLens. But it worked. I knew I was connected because the Thomas, the European space or the astronaut said, "Wow," or "Whoa, that's really strange." And then Kaylee, the second session, she said, "Wow, I've never had a flight surgeon so close to me in my personal space." So I knew that there was a good effect that the crew members felt that we were really there. The images are pixelated due to this 5 megabyte bandwidth, and also the interactions were not privatized. So we need to work on that as well, since there are other crew members in the area. But as a flight surgeon taking care of the crew members, I really did feel connected with the crew members themselves, and really felt like I had a direct interaction and experienced the teamwork and the experience of the human exploration. You know, my physical presence on the ground is here, but we really felt that the entity of our being a human was actually in low Earth orbit. I'll skip over this one. I hope. One moment. Yep. And there are some changes that we are making to our software and our hardware. As I mentioned, this is continuously a learning and iterative innovation. There are a host of folks on this team throughout the different disciplines. And as this whole conference has been fun, it's often when you have the collision and the interactions between these different folks in different disciplines where you come up with these crazy ideas of what to do and where to do it. And these are all the folks that did all the hard work. We think that we can use these holoportation software in other extreme environments as well, to include the Nemo habitat, which is off the coast of Key Largo, the HERA simulation environment here at the Space Center. Antarctica, we'd like to take it there. We see applications for undersea medicine, folks that are deployed, and military folks downrange, like to bring them back to their family members and vice versa. And also there are going to be challenges when we go to the moon and Mars with delayed communications. And as other folks have said during this conference, this really is the future of telemedicine, as well as telementoring and the teamwork we can experience. And we feel a new way of human exploration off the planet. So I'll stop here, answer any questions. We may be ahead of time. And there's my contact information at the top. I'd be happy to answer any questions. Over.
All right, I was talking to a muted microphone. We do have a question in the chat bar. Sarah, did you want to ask your question, or do you want me just to read it off the chat? All right, let's see, where did it go? Oh, it disappeared.
Yeah, yes, sir. I'm still with you. Go ahead.
All right. So the question was, the HoloLens brought up for this specific project, or is it used for other activities as well?
Great question. The HoloLens we have on board for multiple uses. So it was originally brought up for Scott Kelly's mission when it was actually first developed, and it was going to be used for a manner so that he can communicate and experience actually during his nearly 1 year mission, to give him a new environment and to see what it would be like for a crew member to be able to actually, holoport to another location, so to speak. And then also there's been significant work by our entire community to have this useful for doing augmented reality. And so there have been teams from JPL and other groups that have been using this HoloLens to do maintenance and repair, say on the our exercise treadmill and some of the other equipment. So it is available for the community's use. And I didn't mention this, but our effort was a technology demonstration. And so often, it takes you 10 or 15 years sometimes to get your research on board the space station. But if you can come up with a new demonstration or new innovation, often you can do it in this manner, which is called a technology demonstration. And with the proper review and the proper set of team, you can actually get it on board. It took us about 6 months to a year to actually get this done.
Thank you. Any other questions for anyone around the loop?
Great presentation.
Yes, definitely. Great presentation. Thank you.
Yeah, please, anybody. Right. I'd love to collaborate with anybody on this when it comes to human factors and also telemedicine. So again, it's a tremendous amount of fun to work with people. I'm in space medicine, but you guys and gals are all in engineering, and we can really come up with some new and innovative ideas. So thank you very much for the opportunity, Frank.
Definitely, thank you. And yeah, I'll definitely sync up with you after the TIM.